Junior Cycle Higher Level 2011 Phase 1 Pilot, Paper 2, Question 3. So this is a probability question, and we have 500 cars and of different colours. We don't know how many blacks there are. There's 500 in total. The first thing they ask us is how many black cars there are. So if we appreciate there are 500 of them, so all we need to do is take away from the 500 the other remaining colours. Now the other remaining colours, if you work it out, add up to 410. So therefore we have 90 left. There's not much room in there, but there's 90 left. We're next asked to work out the relative frequency of each colour. Now, relative frequency is basically another name for an experimental probability, i.e., according to the experiment data they got, what is the sort of the probability as such for each of these. So, it's 70 out of 500, 100 out of 500, 45 out of 500, and so forth and so forth. Now, they don't give you much room, but I mean it's 70 out of 500. Now, as a decimal, it might be easy to put them as a decimal, and it's 0.14. 100 out of 500 is 0.2. 45 out of 100, 45 out of 500 is 0.09. 55 out of 100, 55 out of 500 is 0.11. 90 out of 500, 0.18, 0.28 for the last one. Now, it's worth a while actually just double checking that you've got it right by adding up these numbers and making sure they add up to make 1. And sure enough, if I were to add up 14, 20, 9, 11, 18, 0.28, and 28, I would get indeed 100. And for part C, this is what it's wanting you to do. It says, suggest a method to check that your relative frequency calculations are correct. Perform this check. So, as I said to you, the method is add up all the relative frequencies and it should total 1. Part D, what's the probability the next car will pass passing the lights will be red? Well, we're working on our relative frequencies. We're using the data we've got. We can assume red is 0.14, 14%. That's the probability of a red passing the lights. So 0.14, or you might want to write 7 over 50 as well. That's in a fractional form. Part E, use the information to estimate the frequency of each colour if 2,400 cars, 2,400 cars in total, pass the lights in a full day. So this data was from 500, but we want it now for 2,400. So we can use the data, we can use the relative frequencies. So if we know the 14%, 0.14, were red, then we can do 14% of 2,400. And we get 336. And then for 20% being blue, 20% of 2,400 is 480. And once we've gone through the same calculation for each of them, we get the following results for all of them. And again, if we were to add up all those numbers, we will find that that adds up to a total of 2,400, which is what we want. Finally, part F. The data collected by students is not a random sample, so that's the original 500. It's not a random sample of cars passing through the day, so obviously there's an issue about the way in which they chose those 500 cars. Do you think this makes your estimates for E unreliable? So for the 2,400 cars, do we think that our data that we got from the 500 will skew the data somehow? Well, to be honest with you, whatever happens here, whatever you argue, you'll get the mark as long as you can give a reasoned argument for it. Now, personally, I would argue that no, that it's not going to make it unreliable. I can't personally think of too many things that can make a set of data of colours of cars be skewed. It's not like, in certain times of the day, business people are going to be driving by in their sort of silver cars or black cars or red Ferraris or what have you. It's. I don't think there's going to be really any changes. I personally would argue that it does not become unreliable, and the reason being is, well, as I said, colours of cars. It's pretty much a random selection. You have certain personal choices, but I would argue that in this particular instance, choosing random sample is not going to, or a bad random sample, is not going to affect them. I mean, where do they pick the cars from? Why would there be a situation where, having picked them in a certain way, it would skew data? You had more colours of one sort rather than another. So it's a difficult one to explain how you would write this down, to be honest with you. But I would say no, and give some sort of reason. Obviously, otherwise they won't give you any marks.